All right, so now we're going to take all the properties that we've learned and solve equations. And so solving equations with logs. For number one, this one's not too bad. Because it's 3 times all of this, I can undo multiplying by dividing from both sides. And so what I'm left with is the log base 2 of 3x equals 3. 9 divided by 3 is 3. Now, remember, all the way in the beginning, going from log form to exponential form, the swoop method or the circle method, I'm going to take 2 raised to the third power, so 2 to the third power, and set it equal to this entire term, 3x. And that gets rid of that log for me. Now, you could have done change of base formula, I guess, right? You could have said log of 3x divided by log of 2 and tried to figure out how to solve for x from there. But I think this is way easier. So 2 to the third power, well, 2 times 2 times 2 is 8. So 8 equals 3x. And if I want to get x by itself, then I'm going to divide off this 3. And so what happens is that I get 8 over 3, or x equals 8 over 3. And so that would be our answer. Now, unfortunately, the second one is not quite that easy. But we're going to use similar properties. Now, when I look at this, yes, it's a lot, but when I look at the left side of the equal sign, I notice that I have a natural log with the same base, and I am separated with a plus sign. And so if I'm separated with a plus sign, that means I'm going to multiply. And so I'm going to think of this as the natural log of this 2x minus 3 times x plus 2. And this is going to be equal to, now if I have a number out in front, that's going to be my exponent, right? The power property. So this is actually equal to the natural log of x squared, or x to the second power. So at least the right side wasn't too bad. The left side I'm condensing into one natural log by multiplying those two terms together. When I do this, let's just go ahead and distribute. So when you distribute this through, you get the natural log of, and we get 2x squared plus 4x minus 3x minus 6. And this is equal to the natural log of x squared. So I didn't do anything fancy. All I did was distribute. And we're going to combine like terms, right? A positive 4 and a negative 3 give me the natural log of 2x squared plus x, positive 1x, minus 6. And this is equal to the natural log of x squared. Now we have this property. Once I have one log or natural log on one side of the equal sign and one log on the other side of the equal sign, then it's called this one-to-one property, where I can get rid of the logs because the logs are equal to each other, so I can get rid of them and I can set their terms equal to each other. So I can say, oh, this 2x squared plus x minus 6 is equal to x squared. Well, now that I condensed it down to just one log on the left, one log on the right, in this case they're both natural logs, so because they're equal to each other, I can set their terms equal to each other in order to solve. And that's the one-to-one property. From here, now to solve, I want to get this in standard form, move everything over to the left side of the equal sign, so I'm going to subtract this x squared from both sides, and so when I do that, what I'm left with is a positive 1x squared plus x minus 6 equals 0, and you're thinking, oh man, he's going to say we have to factor, and you're absolutely right, and factoring doesn't go away, so I need two numbers that multiply to this negative 6, and at the same time they add to a positive 1, and so this is x plus 3, x minus 2. 3 times negative 2 is negative 6, and 3 minus 2 is a positive 1. And so finally from here, now I can actually solve and say, oh, well, the zero product property says that this is going to be a negative 3, and this is going to be a positive 2. So if I take each factor, each set of parentheses, set them equal to 0 individually, and solve, the signs are just going to be the opposite. So a negative 3 and a positive